Good morning. Thank you very much, Hugo and co-organizer, for this nice invitation. It is a pleasure to be able to share with you this morning. One thing that probably I will not need is to present you Duchenne, so let's keep going in this audience. No need to introduce Duchenne that much. So Duchenne is in the focus of the interest of Genethon for many years, and there's ongoing clinical trial and medical program for many years, but in fact, first patient was just being injected in a strategy of AAV microdystrophin, and here's the communication to the press of Genethon, and in fact, in this program, Sarepta is a co-investor, and for the reason of industrial property, I have no right at all to tell anything more than what is appearing on this screen. So it's just to let you know that it is now, eventually after many years, it is really happening. So long ago, in about 2008 or 9, when it has been decided to go into a program, it has also been decided in parallel to run biomarkers program. And a number of groups were involved in a number of different biomarker program for the obvious reason of being able to follow and to monitoring any medical, to follow on medical profits that can become with the program. And we've been interested in circulating MINA because 2007 or 8, it happened, a number of books shown that circulating MINA, that MINA in fact going extracellular and can be used in strategies of biomarkers, and we decided to work on that.
David, could you bend your screen to be full in the center? Very good, thank you.
I don't see myself, so it's better now, sorry. So what happened, in fact, that it took to collect a good cohort of MIONA patients, in fact, of DMD patients, serum patients, took years. And we couldn't start immediately with patients. So in the meanwhile, we decided to develop a number of animal models from studies. And these are appearing here one by one. So along the years, we've been running through mice and dog experiment in a number of paper and publication while waiting, eventually getting serum for patient. And sometime at 2015, 16, we have this cohort being completed and we're able to start the real thing, which is a human experiment. But well, we lost time, but we gain experience and knowledge, and we got better in designing and understanding how to do this kind of studies. And what I'm going to describe you today is eventually the studies that we run with the human samples, and quite paradoxically, it turned out not to be at all biomarker study because simply we thought that more than biomarkers, there's other aspects that could be studied, and this is more, we turn our attention more to pathophysiology. And so also in a very good timing, since yesterday this study is online on the Journal of Cachexia and Sarcopenia and Muscle Disease. And as I have no time to go into details, you're most warmly invited to go into the paper and see yourself in more details. So the cohort composition is described here. So we had 3 age group, and which is between until the age up to 8 years, up to 12 years, and then older patients up to 20 years old. And we also had them treated and untreated by glucocorticoids. And also what you can see is that mutation were quite balanced between different groups. As you can see here, the spectrum of the Duchenne, of the dystrophin patients. So there's already many published studies on biomarker on circulating MINA in Duchenne. So what we had as compared to previous published studies, so we had a relatively large cohort. As I mentioned already, we had the glucocorticoid treatments, 3 age groups, and also what we use is a sequencing technology. It's very much advantageous because of higher resolution. Just you can get not only what you're looking for, but also what you found simply. And to get quickly to maybe the most important results, So this is a volcanoplot that describe many different dysregulated MENA. Depending where you put your threshold, but we have close to 100 dysregulated MENA altogether, much larger than ever described before, and of interest, some of them are downregulated, which also almost never been shown before. And as we had a lot of previous results from animal experimentation, we see more of these results. We see things that we saw before, but many new of them. One in particular interesting group of MENA, a large MENA group of MENA that are coming from the same locus, which is in fact it's a cluster of MENA, the DLK-DS3 locus. We showed before in the dog already the upregulation of these MENA in the plasma of the dog, and now it is confirmed in human. And in fact, in the Padua meeting of 2020, some 6 months ago, my student Ivo Hong was showing a little bit about the activity of these MENA in Duchenne Muscular Dystrophy, and this is a paper that's under preparation. So classically, what happens when you get into this point in these kind of omics studies is that you have so many of them and you're not sure what to do, how to go on. And one classical thing would be to choose to select one of them and to go a little bit into details in one MENA, and this is what we have done in this study. And so this is published about a year ago in Scientific Report, and we focus on one MENA coming from this locus, from these clusters that I just described you, the DLK-DS3, and we identify interesting pathways that link this MENA into mitochondrial activity. And this is interesting because, of course, because of mitochondrial dysfunction in Duchenne, and you know that's a classical accepted model talking principally about the effect of extracellular calcium that will get into the mitochondria. And what we are showing now that also MENA can affect gene expression inside the mitochondria. So the mitochondria is no more only passively getting calcium from the outside, but also in mitochondria internal mechanism that affect gene expression that might be involved. But this is not the subject of today's talk. So in fact, when you have all these things, we thought what to do, how to develop a way to look more globally of what's going on. And in MENA, you do it by looking at MENA target genes. So what are the MENA target genes? If you have all the MENA which are dysregulated, you will go to look at all their target genes all together and try to do kind of summary of things that are happening downstream of dysregulated transcripts. And well, when we've done that, we got this kind of pathway which are dysregulated. So not only these, but in particular, I'm showing these because these are known already to be dysregulated in Duchenne. So there's ECM receptor, fatty acid, focal adhesion, AKT, and FOXO. And so that was nice. It's same time good news and bad news. The good news that, okay, we identify downstream to the MENA all these things that are already known. So it means that our MENA profile probably is correct, let's say, and it confirms some known knowledge in the field. At the same time, it's relatively disappointing results because all these things we know already, and if you do all this effort in order just to finish with something that you know already, it's not allowed to develop new hypotheses. And well, we made some interesting observations while looking in more detail at some of the MENA. So as for example, this MENA, which is 556, we notice that it is hosted by a gene, which is capone, and the capone is inside the NO signaling. And the capone itself is known many years to be dysregulated in Duchenne Muscular Dystrophy. So we have a tandem here of MENA and its host gene. Most of them are dysregulated. And then we look and we in our 100 dysregulated MENA, we found that many of them, in fact, are hosted inside genes which are known to be dysregulated in Duchenne. So if we go back to this scheme, so about half of the MIRNA are in fact hosted within intron or exon of coding genes. And when you look at target genes, the problem of target genes that you have so many of them, and there's a huge problem of specificity and complexity. Because if you have 100 dysregulated MIRNA, you go into 10,000 dysregulated target, in fact, you don't get much specificity. And so we did a little bit of reading on the relation between host gene and MIRNA. And we get to convince ourselves with the literature that the relation between MIRNA and host genes are in fact much stronger and certainly more specific than relation of MIRNA with target genes. So we said, instead of looking at target gene, let's look at host genes. So we done similarly kind of gene enrichment, but this time for host gene. I must stress that now instead of looking at 10,000 genes, we're looking only about 100 of them. So it changed completely the capacity to get more specific results. And when we done some of the bioinformatic prediction, we found in fact that the SREB transcription factor are in the middle, in the heart of a huge network of gene dysregulation. And just very briefly to let you know that the SREB1 and SREB2, which are quite homologous and altogether master regulators of fatty acid metabolism and of the cholesterol pathway. So we asked ourselves what known about cholesterol and is it might be involved somehow in Duchenne muscular dystrophy. And well, this is more the same bioinformatic predictions that put lipid metabolism in the heart of gene perturbation of scheme in Duchenne. And then we identified these papers that coming in a PNAS 2015 from the Stanley Fronner lab. And they treated with simvastatin mice, the MDX mice, and got beautiful results of therapeutic benefit improvement of dystrophic parameters. And they also showed it in the heart in another paper 2 years later. But then we noticed that, in fact, the group of Fronner, what they said that, in fact, it's not directly the cholesterol that was involved. Instead, they suggested that other pleiotropic effects of simvastatin are involved, such as fibrosis, oxidative stress, and inflammation. And this because when they looked in the plasma on the cholesterol levels, they did not see much effect on the plasma. But we thought, well, we're not talking in fact on plasma. What might happen in the muscle will be more of interest. And it is also interesting to note that in the meanwhile, so simvastatin was great excitement some 5 years ago, and other group tried to reproduce some results, and it just came out that this paper that says that in fact simvastatin is not working in Duchenne, and so it is in the middle of a debate at the moment as whether or not simvastatin may do something. So we did our own experiments, and we got some interesting results. And what you can see here is that upon only 3 weeks of treatment of simvastatin, we get reduction of circulating biomarker, such as a classical serum creatine kinase, but also the myomesin 3 that we described some years ago as a very useful circulating biomarker for muscle degeneration. And also very interestingly, we get clear reduction of the fibrosis of the diaphragm in the MDX in only 3 weeks of treatment of simvastatin. So is it related somehow to cholesterol? Our results suggesting that yes, because cholesterol can be stained with philippine, which is very specifically will stain cholesterol, and we can see clear upregulation of the diaphragm and other muscle in the MDX and clear reduction after the treatment of simvastatin. So there's good correlation between what happened in cholesterol after the simvastatin treatment and with some improved dystrophic parameters. We try to understand how this may come, and I just told you that the SREB family proteins are regulator of cholesterol synthesis. And what you can see here is that when you look on transversal section on regenerative fibers that can be recognized by central nucleation, you can see that these are SREB2 positive in the MDX, and they become completely SREB2 negative upon simvastatin treatment. So it seems that simvastatin will affect somehow the control of cholesterol synthesis in the muscle.
5 minutes left.
Yeah, so it's a good point to go into summary. So what we have done, a deeper MIRNA profiling provided some new insight. We developed a novel method to interpret overall MIRNA dysregulation. As I told you, it's just pinpoint on one molecule rather than showing 20 or 30 or whatever, so many different pathways which are dysregulated in the classical interpretation of MIRNA. What's nice about this method that instead of asking what the MIRNA are doing, the question is different. Here's the question is why these MIRNA are dysregulated. So again, it's coming to the question of looking differently or interpreting differently MIRNA dysregulation. We are suggesting that cholesterol metabolism is central to the pathology. We show that simvastatin, and this is in agreement and with some previous paper and under debate, as I just mentioned. So simvastatin and maybe other cholesterol drugs and very rich pharmacology for cholesterol that can be tested. And in conclusion, the title of the paper is that cholesterol might be a target for therapy in Duchenne. And my last slide would be the perspective. Is it important, all of that? And why? Just call your attention to, well, it may be like so many other papers and drugs that were shown to do something in mouse, but never came into translational. But just to draw your attention into this paper coming from the group of Pascal Bernatchez. And what they show, when they knock out ApoE, they got a much severe phenotype in MDX, and ApoE is involved in cholesterol reverse, in the removal of cholesterol from tissues. So it makes sense. If you cannot remove cholesterol from the tissue, you get a more worse phenotype. And the same group just a while ago published another paper that simply defined Duchenne as a dyslipidemia disease. And my very final note is that all these drugs, you may know them, glucocorticoid, simvastatin, tamoxifen, adiponectin, etc. All of them giving some benefit in muscular dystrophy. And I would say for all of them, recently proposed medication, in my knowledge, none of them has a clearly identified mechanism. And the third point that all of them are acting clearly on cholesterol and lipid metabolism. So these are correlation, but I would say these are interesting correlation. Well, finally, acknowledgement of many doctors, medical centers, Thomas Voigt and Laura Servet, that help in running all the medical part of this study, and Stephanie from Geneton, and the group of Isabelle Richard in Geneton, and our partner for this study. And I'm done. And I'll get your question. Thank you.
Thank you, David. So questions, do we have some questions? I'll start with one. Did you look at the difference between the corticosteroid treated boys and untreated?
Yes, we did. It was minor. The great difference is, of course, between Duchenne and non-Duchenne. Treated, non-treated, there was no overall MIRNA profile shift, but there was some specific MIRNA that were moving, and we give the list in the paper. And one of the interesting MIRNAs that were moving is the one I just described you, which is a MIR 379, which was very much the highest among all of steroid response. And again, this is interesting because we show that this MIRNA might be involved in signaling into mitochondria. So we are kind of suggesting that glucocorticoid may affect mitochondrial functions through this MIRNA. And then there's another list, small list of other MIRNA, which are glucocorticoid responsive. Yes.
May I make a short question, maybe unrelated? I remember that there were claims in the past, maybe 10 years ago or more, that statins produce muscle damage. Is this still an issue, or that were bad news, fake
Absolutely,
news?
absolutely. So myostatin toxicity, not myostatin, sorry, statin toxicity is a big issue. And of course, if you are proposing to treat Duchenne boys with simvastatin, immediately you get...
Because for a general pathologist, the damage could be the beginning of recovery. And some of the evidence could be just to increase the muscle regeneration, but unfortunately through a damage to the muscle. Did you make test this crazy idea?
Not really. So we are not much deeper. We have some preliminary results, but I will not develop on that. But the only comment that in this context that interesting to do is that also glucocorticoid is bad for the muscle if you're not Duchenne patient. So the fact that simvastatin may harm in overdose the muscle of a normal person is not automatically should be taken against use in condition of Duchenne muscular
Let
dystrophy.
me finish saying that I am on myostatin treatment, and therefore I am interested personally.
Yeah, I take myself statin now for years. So among all statins,
I'm sorry for interfering in these
no,
scientific
this is highly relevant.
activities, but it was my occasion to acknowledge our 40 people present and remember to all speaker, please stay in 20 minutes, possibly, in discussion included. We have a very, very, very long day. Good work to all. And thank you, of course.
Thank you.
Okay, do we have any more questions? David, if you stop.
Yeah, I have one more question, if I might.
Corrado?
But
Yes.
yeah,
Right.
I enjoyed your talk, and I want to ask you something about these biomarkers, because I mean, you have a picture where we had, I don't know, 100 biomarkers, some myomyrna that I know about, some cardio. So my first question is about correlation between CK and myomyrna. I mean, do they go the same way? Have you followed in time? So, and what about the other biomarkers? Do you think they could be useful in the follow-up? Have you done any follow-up study?
Yes, so among men which are dysregulated, of course, there's a classical group of the myomere, which are MYO1, 133, MYO 206, and these are showing a quite similar profile to the muscle creatine kinase and also similar to the myomesine 3 that I was mentioning. There's quite good correlation, although not absolute correlation. So there's some divergence between both of them. Between all of them. But then, of course, there's all the other, and we haven't went deeply into biomarker, into characterization of the potential of biomarker of all these. We have too many of them. They will not show the same as a myomere. The myomere are among these that are going the highest at a young age. Just classically like the creatine kinase, and then we drop down with age. So in fact, beyond the age, so something that I did not mention, that in fact, we had also the group 12 to 20. We had 3 age group. And in fact, when we looked at the overall dysregulation, we excluded this group for the reason that almost all dysregulation disappear beyond the age of 12 years old. So I would say myomere, yes, are similar to creatine kinase. Other myrna are different, and altogether there's sharply reduced dysregulation after the age of 12 years old. Is that answering?
Yeah, I have the impression that this myomyrna under 2 regulation growth of muscle, but also destruction of muscle. So which one is the most important?
So I'm not sure I understand exactly the question. Can you repeat in fact?
Yeah, I have to shorten the discussion because Hugo is
Yeah,
getting. So the question is, are they for regeneration or do they signal muscle disappearance?
So that would be individual. Many of them are coming up in young myofibers. For instance, the groups that I just mentioned, DLK, DU3, which are also, they are coming in young. They are expressed highly in muscle stem cells. Then they will go down upon activation and will go very up in regenerating myofibers. So definitely they are signaling regeneration, but of course muscle destruction is participating, and many of these probably will go into the serum simply because fibers are destructed
Okay,
and
thank you.
massively going